Welcome, everyone. Thanks for joining today. We have an exciting discussion. We're going to talk about how we use IIoT and AI to extend grid capacity, so all the way from planning to capital decisions. My name is Suman Gautam. I am CEO and founder of Adi Advisory, and I'll be leading today's panel. We are an advisory firm dedicated to accelerating clean energy transition for vendor and energy growth companies that are planning to expand in the U.S. market or enter in the U.S. market. Our services include ranging from market development, pre-revenue capture, regulatory policy advisory support, investment advisory, including buy side, sell side, and strategic acquisition, and executive placement. We pride ourselves in deep energy and utility market expertise and our collaborative approach. Uh, that's enough about me and my firm. I'm very excited to start our conversation and pass the mic to our panel members here. Before I do that, just a quick housekeeping items. Take a look around and familiarize yourself with the tools here. There is a chat window, and use it and tell us where you are joining us today. And if you have any questions, use Q&A tool, not the chat option for questions. We will take as many questions as possible towards the end of the session. So without a further ado, let me introduce our panel members here. And panel members, I would love you to introduce yourself and provide one insight into what you are doing in extending grid capacity in your role in using AI and data-enabled IIoT systems. So on my screen, Rohit is the first. Rohit, please go ahead.
Yeah, thank you so much. Looking forward to it. So I'm a senior process engineer at Atlas and also independent researcher with over 10 years of experience in plant design and industrial AI optimization. I specialize in designing chemical industries with the high capacity and also integrating AI into a process industry and operator side, hence extending the grid capacity from the granular level. I have an intersection between chemical engineering and digital transformation, along with an MBA which connects techno-commercial aspect lens when we are looking into the technical details of it. My work in the field of sustainability and grid is particularly with reduction of 70% GHG emission, and I'm here to provide insights on how process industry from equipment gets data into the grid through edge computing. Yeah.
Great. Anirudh, go ahead, and thank you for sponsoring our session as well, FedShift and Cyrus Link. Anirudh?
Yeah, thank you very much, Suman. Everyone, great to meet you. My name is Anirudh. I go by Ani. I'm the CTO and co-founder of FaceShift. We are a company that does data normalization and transformations in agentic AI at the edge for our industrial customers. Just so happens that my co-founder and I both kind of started our careers and have been in the energy storage industry specifically for a long period of time, and began to realize that this problem that we've been talking about today of disjointed data, lack of normalization, lack of good namespaces, things like that, is really a problem that's shared across multiple industries. And, as they say, in your career, you can connect the dots backwards, right? So before I was in energy, I spent some time in defense, and it's the same problem there, right? It's always a data protocol that you have to get data from. And so, creating those actionable insights is what we focus on. And so I'm happy to really shed some light on that with the panel here today.
Good, thank you. Gary?
Hi, I'm Gary Tillery, CEO of Skkynet, and so I'm really happy to be here today with this distinguished panel. And so Skkynet actually provides security, so we get your data from the edge to anywhere, including AI, but we do it in a secure way so you don't have to worry about having outside intruders coming in. My background's in software development, system design development, and the industrial automation side of things as well. And so I'm just glad to be here, and thank you for sponsoring, and thank you for attending.
I think that leaves over to you, Travis. Go ahead.
Perfect. I was just waiting there for you. Yeah, so hey, everybody. I'm Travis Cox. I'm the Chief Technology Evangelist at Inductive Automation. I've been with that company for going on 23 years. And it's crazy to kind of think it's been that long. But our focus has always been on providing the right industrial application platform for operations, to be able to get at the data that's down there from different systems, bring that together, unify that, add context, and provide that data to other systems or to people through applications. Really, been focused, and over my career is helping customers and integrators build those right foundations and those solutions that are required, because you have to have the right foundation to ever think about going into analytics or AI or any of those pieces.
That's awesome. As you were discussing, I can already see how much operational insights that you will bring to this conversation today. So we will go through our panel discussion. I thought that we will do it on 3 phases, right? So on how we use data foundation in 3 phases, starting with planning, and then we go into how is it used in terms of getting investment approval, whether that's internal or external regulatory approval. That's in US, that's a pretty big deal, and then the operations. So we will frame our discussion across those 3 pillars, starting with planning on building the data foundation for AI-driven intelligence. Anirudh, you talked about it briefly, that before any AI can support planning decisions, that underlying data plumbing has to work. And through your current role and in past experience, you have built the systems across multi-gigawatt renewable portfolio and with dozens of OEM integration. From your experience, when that AI-driven planning fails, what is usually the case? And how does the data architecture look like, when it's working?
Yeah, I've been thinking about this problem a lot, not just at Phase Shift, but kind of at the industry-wide as a whole. And I really think I could sum this up with data fatigue, and specifically alarm fatigue. All right. So in the past, I've worked with systems where, one system would fault out and generate something upwards of 20,000 faults or 20 to 30,000 alarms across the entire fleet, right? And so what we really want to solve in that case is we've solved that we have all the data problem, but we don't know what to do with this, right? And that's how we start getting into the questions of how could AI help in those kinds of decisions, right? Or being able to either diagnose the problem or figure out what the problem is. And then that lays the foundation for how do you expand the fleet or how do you extend the fleet going into the planning question. So I really think that it really comes down to that solving that piece first, which is really understanding alarm fatigue and how operators work with data. Because really what we don't want to do is just have AI feed another dashboard. What you want is AI feeding something that actually can make decisions with a human in the loop. And that's why we keep talking about how this foundation of data is so important, and kind of the way about which we do that, which is of course everyone's familiar with in this today, and some of the sessions today talk about UNS namespace, and there's different strategies to get there, but that's really, I think, the problem that needs to be addressed.
Great, Anirudh. You mentioned UNS namespace there. Travis, anything that you would like to add from that perspective?
Yeah, this is a very big trend now, kind of really understanding what this means and how you can approach it. There is no one answer in terms of how it can be done, but what it really is organizations are thinking about data differently. Historically, when we would build a system, we would, like if I was building a SCADA system, I would be thinking about what's required in order for me to build and to operate that SCADA system, right? Get the data to the right operators. And then it was kind of an afterthought that later, oh, maybe that data is useful for the business. And we got to figure out how can we get that data now from that SCADA system to the business or from a historian to the business. And at that point, did we do all the right things so that it's the business side understands that data right away? And so this concept of UNS is really thinking about differently, sort of that almost decoupling, right? You have your data, your digital infrastructure, your data infrastructure, and leveraging different standards and protocols and technologies, we can have a foundation that everybody can tap into and understand and get the context right away. And that context is really important. You've got things like hierarchy, relationships. A lot of people following like IS-95 models, things like that. You've got the engineering units and the expected range of these values actually are. You've got data modeling. So what is this asset that I'm looking at? And are we consistent with that across our organization? Are we using the same data modeling everywhere? Because the more context that we can build into those systems, the easier it is for analytics to do their job and to be able to take that information and go further with it, because it's understood. I don't have to have any translation or mapping or, it used to take, when people wanted to approach ML, machine learning, they would take a data scientist getting data out, cleaning it, trying to figure out what these things represented, adding that context, and then using it in tools. That wasn't scalable, right? We've got to be able to do that right at the edge on that foundational level so that we can build that infrastructure that then enables that next level. So that's really what I think UNS is really encapsulates. And organizations, they have to be the one to drive it. Vendors aren't driving it. We're fitting into their infrastructure the way they want.
Travis, are there any organization or any industry using that right now, or your team helping using UNS?
Yeah, it is absolutely being deployed out there. I mean, you see a lot, especially in manufacturing. That is one of the leading industries in this realm, especially when you think of Industry 4.0 initiatives. But it's also there. I mean, very much renewables and data centers. Where you do energy and power management or building management, or you could build those infrastructures because the scalability is a real thing. We'll talk about that, I think, as we go throughout here, but I got to put it in place. And then later I've got to add more assets and more locations, and it's got to be able to fit right in and scale the way we want it to and not break down. And that is important. So all these things are being taken into consideration right now when looking at these new systems. And leveraging protocols like MQTT and others, there's lots of cool things that are out there today.
Yeah, great, thank you. And Gary, you mentioned earlier in your introduction how your team uses AI in a secure way. From secure data transport perspective, can you shed some light in terms of how that is critical in planning phase?
Yeah, it's critical to Skynet. When we built the Cogent Data Hub product, we built security from the very beginning. And we think that you have to consider that in the planning and design phase as you're building and architecting your system, your solution as well. You can find that security teams are increasingly getting involved, like in the OT architecture decisions, for a lot of good reasons, right? Security is important as you're moving data from on-prem, one domain, moving it into the cloud. You don't want to open up a port, making that bi-directional, because then you open up a port for, bad actors as well to come in. Security is a much bigger and broader thing than just firewall ports. Not trying to claim that, but IT plays a part in that, other aspects. But in this, when your network and your OT networks, security becomes greatly more important, I guess, as you want to look at that. You don't want to just solve the data integration problem, making it easy for yourself. You want to really ensure that the security access to the data that you have is approved, for approved consumers, and you want to prevent, any unauthorized consumers of that data.
Yeah, it's very helpful. And I'll open to this all panelists here before our another theme for today. We talked a lot about planning in terms of normalization, standardizing this process. In your experience, on that, as we are developing that process, what usually does it break? Is it a protocol, or is it organizational, things, or is it something else entirely?
I can start there. I think it's not necessarily a technology problem, right? There are lots of technologies available and are accessible to, easier than ever, to get it actually put in place. I think a lot of it more is more of a cultural, is more of an understanding of how we can, that if I want to do digital transformation, it's got to be throughout my entire organization. Leadership's got to drive that through. We're all working on the same initiatives. So we've got to understand the use cases that we're trying to go after, and being able to not take on everything, figure out a use case, drive that, have everybody understand their role in that, so that we're working together on those objectives. Because if we have teams doing independent things, you see these kind of siloed teams doing their own stuff, and one team doesn't know about the other, you don't get the overall value that you could be getting if they were driving it together. So I think that's a lot of where we're at today. Is it's up to the organizations to determine, what should be done there.
It's also, to piggyback on what Travis is saying, like setting the vision for the customer on the power of doing something like that is also, I think, a joint effort from all of us, right, in the industry. Because it's easy to say, a customer should have a digital transformation, and they generally have pinned somebody to the project to be able to lead the charge. But we spend a lot of time, at least we find ourselves spending a lot of time explaining what the true value is, and it's beyond just the sale, right? It's really thinking about how does this scale their operations in the long term. It might seem something like it's not paying off, or right now it seems like a lot of work, but there really is, you're unlocking a lot of value for the customer at the end of the day, and that's kind of the sort of message that we keep trying to drive home.
Putting perspective in a heavy industry, so there's usually the challenge that comes as explaining how this AI model can provide the difference between having it versus not having it, and realizing in terms of financial metrics. The essential thing that companies like us has struggled is, what if things, because the issue that AI resolves in terms of a compressor not working, or AI recommends it's stopping XYZ amount of time. In that, what the realization of financial metrics, proving that aspect was difficult, and that's where the incorporating the planning at the start and ensuring and explaining it to the leadership. Okay, this is the process that it happens, and what if the AI recommendations that come in, and human in the loop, they gets to detect and recommend, accept the changes. That provides the value in terms of financial metrics.
Yeah, these are great things, and I kind of can't disagree with any of them, but it is definitely on the organization, the culture, and the DNA. It's the strategy that you set out, and it can't be just always from the top down. You need to consider the challenges that the teams that are actually doing the work are actually facing as well, and have input into that strategy for what you're trying to accomplish with any kind of transformation. It is definitely, technology is not really the barrier anymore at all.
And if there's one more thing I could add, which is, we live in a very legacy world still, right? There's a lot of legacy devices, legacy assets, and things that we can't just overnight replace or wave a magic wand that we're going to have this beautiful new infrastructure. It's built in parallel with what we have. And I think that's a really important piece. It's to say, okay, we want to digitally transform. Here's a particular use case we want to solve. We're going to put in new sensors, new things. Teams are going to be aligned on that. We're going to figure out the right architecture we want, what the infrastructure is, the digital infrastructure we want beginning, have everybody understand that and drive towards it. So they think about security. They think about where that data is going to go, what we're going to do with that data, who are the consumers of that data. If we can answer those questions up front in the planning process and have people aligned with it, it goes so much faster and better.
Exactly.
Great, and that's a perfect segue to our second theme of the discussion, right? So we do this planning. How do we get what does that approval process look like? And we can build in this planning phase. You can build sophisticated models, but that approval process, including as you all know, the utility regulators or investment committees, internal companies, investment companies, they demand a different kind of evidence. Let me start with you, Rohit, in terms of, as we're building this 9-figure capital investment decision using this planning approach, what does that data audit actually look like, and what are regulators and investment committee, what do they look for?
Yeah. So the way I look at it, so the investment committee internally, when we're approving a massive update, particularly associated with the process industry or heavy industry, the conversation completely shifts from does this AI work, from what happens, who takes the blame, or what's the exposure if it doesn't work. And this conversation is not about funding the algorithm, but this is us connecting with a critical physical asset. So the audit, how it looks like, is essentially broken into just two metrics, two sections. First is normalizing data, as Anirudh pointed out earlier, because we have to be ensure that the financial metrics and the data is real, clean, and also pulled from the equipment itself. That is the edge, and it's not based on some hypoth or theoretical cloud model. And secondly, within that, the next layer is the physical safety aspect of it. So we cannot rely everything on the AI and making changes to the physical safety. We have to ensure that the engineering guardrail, all the thermodynamic modeling and everything is there. And is that will be a guardrail. If something goes wrong, AI cannot change those aspects. And moving on to, you said, what from the regulatory perspective, rejection. So good AI doesn't mean that it can get approved. So there are three essential reasons that we look into, or aspect that we look into. First is risk asymmetry. Second is regulatory mandate. And lastly, operational reality. So when it comes to the risk asymmetry, we really want to understand who gets, if the grid or the equipment goes down, who bears the responsibility of it? Is it the software company or the IoTs, the sensors company? What? So how does this architecture look like? Who is responsible on each stages, and the risk has been shared? The internal committee has to understand how that works. Secondly, the regulatory mandate. Does it follow the regulatory mandate of each individual region? Because there are so many regions, they have their oversight committees, whether those regulatory aspect has been met. And within that, AI itself requires a massive amount of energy and cloud computing. Does it violate its own sustainability goals and mandate? It has to check whether there's an overlap on it. And lastly, which is the most important, is operational reality. So when an engineer or operator are sitting in an operating room, he needs to be comfortable to understand not just the black box of AI, what's it doing, but he should be able to override the emergency when AI interferes. Like if there's an emergency, the operator should be comfortable to overwriting that AI. Okay, no, that's again going back to Anirudh. He mentioned about human in the loop that build trust, that gets the approval done. And lastly, the AI recommendation can only be approved if we are able to track where the data is coming from, is it clean, and it's also secure. And that leads me, I think Gary and Ani, it's their specialty, and that's where they work in.
Yeah, that's a great insight. And I'll, because Anirudh was mentioned quite a bit of time, let me go to you, Anirudh, real quickly here. In terms of planning from data provenance perspective as well, right? So that I think the planning, standardization, all those, that history comes here. Can you shed some light?
Yeah, there's the joke that we make is no one really cares about the data until something goes wrong, right? So when something does go wrong, you need to be able to figure out what went wrong in excruciating detail, especially for a customer. When you're talking about multi-gigawatt style renewable assets, whether it's renewable or industrial, that really matters. So we've spent a lot of time at PhaseShift trying to figure out how do we prove data provenance for our customers. So all the way going back to the left in terms of the actual asset at the site, the data provenance, the actual, where did this signal actually come from, and being able to prove kind of in a linear fashion how it transformed through the system, even if AI was involved in that normalization aspect, or if AI was involved in actually making a decision based on, like Rohit said, a theoretical a signal that was calculated based on a real asset. When we think about auditing and compliance, right, all of that is really, really important. And the system that, customers should pick, should be able to prove that as well, like in a very defensible way. I think that's really what's important, especially as we talk about deploying more AI agents into these kinds of critical industries. Is you got to know, where did that data come from, so that you can always backtrace, right? And that's been a key for us as well.
Great. So we talked, Rohit and Anirudh, you talked primarily from what needs to happen. Let me get to you, Gary, in terms of multi-stakeholder data access purposes, right? Especially when the capital decisions are made, it involves multiple stakeholders. Like we have regulators, we have operators, we have third-party analytics providers, vendors like yourself, each needing different slices of operational data and other data, and then at a different permission level and latency requirements. How do leading organizations distribute that data without compromising OT security, from your point, Gary?
Yeah, or from our experience. Yeah, so for the next hour, I'll answer this question. It's one of those that can go long, but this is really where the architecture starts to matter at the business level, right? It's not just the technical pieces. The instinct that many people had, I guess, a lot of times in organizations, is really to kind of solve the multi-stakeholder problem, giving everyone direct access to the source, right? Essentially replicating connections to the OT network environment for everybody that needs that data. That doesn't really scale. Actually, Travis touched on a little bit earlier around scaling and things and we've seen, and I'm sure you have too, everyone on the panel here, that doesn't work. But it's really about, more importantly, it's multiplies your attack surface with, every person you add. And I go back to that attack surface again, because there are people outside your organization that would like to have access to that data or your network. So the model that actually we've seen work and is the publish subscribe architecture, where the OT environment really publishes data once and securely outbound to a broker, a broker layer. And every authorized consumer, whether that's internal planning team, regulatory reporting team, third-party analytics provider, subscribers, they exactly the data they need, they're entitled to see. So there's an entitlement piece with that as well. Ties back to the planning and your design. And the latency and the permissioning, that you have, it's, by your role maybe, but also by your need. But everyone has the same information. So the grid operator is never, doesn't have to reopen the OT network or the parameter to each person. The new consumer is onboarded to that broker level, not at the source. What that means is capital planning, specifically with say a CFO's dashboard, regional grid operators, control view, and AI doing 5-year capacity forecasting, can be drawing from some live operational data with confidence. The data is consistent, the data is protected, and it's the access model is audible. So that's really the kind of infrastructure that we see that it does support that trust. And you're hearing trust a lot because it's a big piece of this when you're talking about AI and your data. But that's what the trust is required for major investment kind of decisions from our experience.
Yeah. And then getting into that trust, Gary, is that the biggest, and let me get to you, Travis, I think I know what you will say, but let me ask you anyway. Is it trust between when something is presented in front of regulators or investment committee for approval? What is it that using AI, right? So what is the problem? Is it a trust or data or model in a problem?
that a question for me there, Simon?
Yes. Yep.
Yeah. So like going back to Gary, like, trust, is incredibly important throughout that. And one thing I was going to mention in terms of the architecture is it is very much a layered approach, right? In terms of there are segments of the network, and we have to kind of respect, firewalls and how data is going to move through, but it's got to be, IT and OT working together on what that flow looks like. When IioT first started, what was that but an end run around the architecture, the network that was there to go straight to a cloud service to start taking advantage of those sensors, right?
Yeah.
We've got to have the organization understanding where the data is going, the governance around that, and that the data itself is trustworthy, and that is where I think defining it as close to the edge as possible, where we have the right context, we have the right information, and we can build that quality into that. That establishes that everywhere that goes, I don't have to. It's not being remapped. It's not being put into different tools. It's that single source of truth aspect. You can't really build that trust in the data and the systems without having that. And that's gotta move to the different layers as well, securely and not be dropped, right? Store and forward, and various techniques have to happen throughout that. And these are challenges for a lot of organizations, because you have to have the right infrastructure in place for that to happen. So when you get into analytic and AI models, that it's working off of the right base. Because if we're working off the wrong base, what do we have? Garbage in, garbage out, right? We're not going to get the outcomes we really want. We've seen that in the past. So I think this is the kind of one of the most fundamental parts is you have to establish the right trust of that data and the right trust in the infrastructure to deliver that where it needs to go.
Good. Any other insights, Anirudh, Rohit, Gary, in terms of closing thought before we move to our next theme, from your perspective?
Not really. I think we between myself and Travis, I think we pretty much covered that. It's an important thing because it ties back again to that planning aspect as well, and not just technically, but also your organization as well. And you have to design that in.
100% agreed.
Great. So we talked about planning. We talked about this approval process. Now let's get to fun part in terms of operations, right? That's what we are trying to get to, in terms of how do we run these AI-enabled grids reliably and sustainably. And as we go through this discussion, audience here, please feel free to type your questions on Q&A panel. After this, then we will start taking questions. And let me get to you, Travis, in terms of, I think Anirudh talked about a little bit in terms of alarm fatigue earlier, but let's dive into this a little bit more in terms of the remote operation centers are being asked to manage, fleets that grow faster than like headcount. And can you, with your examples, things that you're working on, and what can you give some example where the data structure was used to solve that alarm fatigue that Anirudh mentioned briefly, and what made that difference?
Yeah, so scalability. When you get something running, right, and you're operating it, it's going to grow. Things are going to change. It's going to evolve, right? And having the right foundation really can lead to a much more scalable, architecture and approach. And so first off, it does come down to really this kind of object-oriented design approach, right? This is very common in computer science realm, but doing that within operations, where we're building the right models of our data, we're building the applications to be more dynamic and driven in that way. And now we're like leveraging our, the deployment options out there, deploy things through containers or Kubernetes clusters where it can be centrally orchestrated and managed, so that I can press a button, I can get a new site deployed, pulling my configuration down, getting it up and running very quickly. This becomes it does seem very complicated and far-fetched for a lot of customers because they're not really quite there yet. But bringing more of those IT philosophies and technologies into this realm can really stitch this together in a way that allows these systems operationally just to become easier to manage, to upgrade, to add on to evolve and change, and to track the changes of these systems. So that part, building it, thinking about how you want to build it. Don't do bespoke type installations, right? Thinking about the right approach lends itself well to doing these efforts later on, and especially if you're leveraging AI. When you have some new, if you build the right data models, you have some new approach that you want to bring in, you could apply that instantly, test it on one of the assets, and then apply it to everyone you have in your fleet really quickly and easily. So these kind of techniques can become really important when you look at that overall scalability that are there. Now, for operators that are running these things, they have, like you were saying earlier, the alarms part is a legit issue that's out there, right? There's companies that spend weeks, if not longer, on rationalizing what the alarms they have, to what risk and business factors and outcomes that are there with those alarms, to prioritize them properly, to get rid of noise, and this is actually a lot of efforts that AI can help us do from the get-go. We can create a much better rationalization system that and to kind of distill a lot of that as one area. Another big piece is we'll have these big control rooms, right? We have control room, hundreds of TVs on the wall. We're managing. It's and you're just hoping for, when you see a big red flashing light, that something's going on. Is that the way that operators are using it? It's about leveraging the data the right ways and what's important to them. We kind of said that a little bit earlier, but this is where AI can help a lot too, because it can get that live context from these systems, and to be able to provide that in different ways to the people that are running these systems. They don't have to be in that control necessarily, but they can go there and quickly pull up things and get what they want. So there's a couple of areas I think that are really changing, depending on how you lay that right foundation.
Great. Anil, is there anything that you would like to add from your operational and experience that you have with FaceShift?
Yeah, just a couple things to touch on. I think it's important to note that, like, as we're designing these systems, of course, the best practices using UNS and normalization transformations is really, really important. But I think it's also really important to understand how a ROC operator thinks about the site itself, right? And that's kind of what Travis was alluding to here, is that you walk into a ROC room and there's like 6 different screens on a wall and everyone's looking at a different page. I think if we do this correctly and deploy AI in that kind of model, really the success is how many screens can we eliminate from that ROC wall, right? And the way to get there, I think we've all got line of sight. We understand that the system itself needs to be dynamic. We need to be able to prove data provenance. But what I specifically mean by the system needs to be dynamic is that we have to learn from how the system actually operates, right? So when an alarm or a fault actually gets triggered, what does it mean? Did it actually take the site down? Are there procedures in place that need to be applied? Could we standardize those procedures and then apply it to an agentic workflow of some kind? So those are some of the questions I think that, as we're thinking through how to really enhance the ROC operator's life, because that's really, I think, the ultimate goal in terms of operations, scalability in operations at least. That's a key, I think, North Star to kind of keep thinking about. I've known many ROC operators in my network. I've worked with plenty of them, and they say, well, I do these 6 things when I walk into the office every single time I come in. It's like, well, how long do those 6 things take? If you scale those and multiply that effort across all the sites that you have to manage now, that starts to become, really untenable. And so that's a key thing, I think, to focus on as well.
Excellent. Gary, is there anything to add from vendor lock-in perspective?
Well, I'm against vendor locked in unless it's my company, Skkynet. Right? But no, seriously, it's when you talk about the things we're talking about, they're very architectural in your system, and so you're going to embed these systems into your operations, and it's not something where you just unzip it, pull that piece out and put another piece in. It's not that simple, as you know. And in many industries, and especially in this one, there's a lot of bespoke applications. There's a lot of proprietary hardware and protocols and things like that. They're existing. And like Travis said, you can't just go replace all of those. This is not utopia. You have limited resources. You have to be smart about it. But you have to be smart about the vendors that you're choosing, and you have to find the vendors that are very collaborative. I find this panel, this is not the first time we've met each other. Very collaborative. You go to different conferences and we see each other. You see more collaboration happening. And so when you're evaluating and comparing, you need to kind of think about that as well. Just the domain experience that they might have in your industry, the knowledge, the technologies there is important, but you want to find that collaborative vendor as well that not just works with you, but works with other vendors and other service providers, I think, to kind of hedge your bets that way.
Yeah, thank you. Rod, let me get to you from operation different perspective. You mentioned earlier about carbon neutrality, something we always think about reliability as our first priority, and cost, and obviously carbon should be up there, but it's usually not. And you come from the processing experience. Can you talk a little bit about how that, if we integrate AI in terms of your operations, how does your decision making changes in terms of carbon neutrality?
Yeah. So carbon neutrality, when we talk about heavy industries, there's very little that we can do because it falls under scope 1 and 2, which is there, and we have limited control on it. So a little in that. So if we reduce some percentage, that goes a long way because it changes to the process on a fundamental level. So when I say that any additional AI which can reduce water consumption or steam consumption in a process, even with some fraction, it goes beyond because we uses 650 kTA per annum, if that's the capacity of a process material going out. Few percentage in water consumption and less, that goes beyond that goes long way, particularly for scope 1 and 2. And the question that I was thinking, we heavily use AI to reduce all this consumption that we think it will reduce the GHG emissions. But how much are we putting in because there's a whole demand going on and there's a debate how much AI itself is using the energy. So working towards that neutrality is something that we are looking forward to and trying to establish how we can convince it to the operator side.
Great. Audience, again, we have started getting great questions here. Feel free to send your questions more. I have one closing question for all of you panelists here, and then we'll get to a Q&A session. And I have a few as well questions here. So from your, and this is for all of you, from your experience, what can you share technical challenges, 1 or 2 technical challenges, if that is solved in next, let's say 2 to 3 years, that would change everything for AI-driven grid management?
Well, I can
$1 billion question here, so but I'm giving you, like 20 seconds to answer here.
Yeah, I can jump in really quickly. I don't think there's really a specific technology barrier that we can point to. Somebody can always come up with something that we're not thinking of, but to solve certain issues, it's really, I think we got to become better listeners and fully understanding the problem statements that are coming. We kind of define those problem statements with our customers and also service providers as well. I think that the collaboration piece and then trust as well on not just the technology, not just the, aspects like that, but it's also between each one of them. You got to select your teams well. that you bring in, and don't choose them just based off technology is what I'm saying. But that's my feeling anyway.
I'll say that we talked a lot about laying the right data foundation. Anybody who's actually done that, done the exercise, you know how long it takes, you know how hard it is to basically get the connections to the devices, get the data in, figure out the right mappings, add the context. And we spend a lot of our project building that before we even get to any of the actual value out of that data. I think as an industry, one of the big challenges that we could address together is how to shorten that, how to leverage standards and ways of being like your data, your model isn't special. What you do with that data is special, but we shouldn't be thinking about how we model it. That should be a done effort. We should be thinking about more of what we can do with AI and all these amazing technologies that are there. I think as an industry, we can solve that problem together and make that just a non-effort, even though the world's, we know the legacy world's kind of chaotic. There's a lot of different things. We can distill that, make that simple. The platforms are there to do it.
I agree.
Yeah. And moving, that's on the same top point. I feel like the biggest challenges comes to the process industry is maybe like a consumer behavior, what we can say in marketing. Like the operator are ingrained in the legacy procedures and operations. It is challenging to convince them to rely on something that they are not aware of. So the next few years, with the collaboration of everyone, have to create a framework where in step by step, they are trained to trust the process. And from the safety perspective and also from the financial perspective, what are the advantages of doing so can bring to the company itself?
100% agree with everyone there. And I think just to add to that, I think if there was one theme that I've thought about a lot was since starting PhaseShift is like how much you could do at the edge, right? But Travis alluded to this early on as IT and OT working together. Rohit was talking about sustainability of AI, right? We walk into these customer calls or sales calls and think about, well, I guess I just need to get my data up to the cloud and I can deal with it then. It's like, actually, not really. Like, let's unpack this a little bit more and think about where the best place to do a lot of this normalization is. And it's not just normalization; it could be agentic workflows too, right? And so, I think it's really, coming at almost at left field with customers is like you don't really need to just immediately have a cloud compliance group. Like, let's talk about how the project is structured, and then figure out where we fit into your story so that it gets the customer more comfortable with accepting some of these new technologies and new approaches.
Yeah. Well said.
Great. I have a couple of more questions, but I'll get to it after I get a few from the audience. One from regarding the issue on cyber attacks, even on power grids, right? So from your experience and things that you have seen, how is AI and IioT has been used in terms of responding or curbing cyber attacks and on power grids?
So make sure I understood the question again. How are we responding to the...
with innovative quantum and AI being used to cyber attack, even power grid, what are your views on preventing such incidents?
Yeah, the quantum encryption and things with open SSL. One of the things we do, we actually incorporate that into our product as well for quantum encryption protection as well. But then again, there's just good design on the side of your engineers and designers on the architecture. You don't want to, in our opinion, you don't want to open up firewalls just bidirectional. You want to move the data out, transport it in a meaningful way with a lot of thought around that. We have tunneling technology can handle that, and you can then also you can do things like segmenting your network and things internally if you get a bad actor in, those type things. But there is a whole aspect of cybersecurity because it comes in through the email, and can spread that way in your network if you're not careful. I don't think any of us are in that space. But we definitely, like I know with inductive, we both play in the space where we're trying to protect the network when we're transporting data between domains or sites or into the cloud and things. But we do see quite a bit of that. Like we do a lot in solar and wind energy as well. We have quite a few use cases there, and that's one of the areas that we get chosen for because of this secure aspect. We build it in from day one, and everything in our company is around security. I mean, you can't have a conversation with your legal guy without security. Your technology, your technical team is security. I think the guy that mops the floors, we talk about security with them too. So it's in our DNA, and it has to be, and it has to become part of yours as well, to protect your data.
I will add on that, while we want to do as much as we can from a design perspective to prevent these kinds of attacks, when you look at, there's two ways we kind of see this, right? A lot of AI has been just getting data read-only way, looking at it, leveraging it to get insights, right? And there's lots of things we can deploy that Gary said about how we can make data go out and not come back down to the network, right? Kind of protect that layer. But when we do want to do control, especially any sort of AI control, assisted control, that's where you're saying do it at the edge, right? There's more technologies and compute power that we could do right there. We're not having to go out to the internet at all. We could stay all within the bounds of our network. I think those become really important. But most important of all, you said this earlier, is we have to have, for understanding our risk, we have to have good auditing with everything that's going on. We have to know if something were to happen, would anybody know that it happened, right? Would anybody know that so that we can take an action afterwards if that thing had happened, right? Shut down the plan or whatever it might be. So these are things that auditing becomes just crucial. You have to think of that for all the way through and how, what's happening within your systems.
That's an important aspect. It's how you respond to the incident that becomes critical, right?
Great, thank you. One question from me to all of you. I know we talked about the challenges that it will be solved, in the next 2 or 3 years. I'm going to ask you more in your own work. What is one exciting thing that you are working on, or use cases, things that you can share that you are most excited about?
That we can share. A publicly traded company. Let me think about that. Well, we're definitely investing in AI, right? And for our company, AI means data, getting data to AI. But we also are focused on the edge, like what Travis was saying as well. We're expanding our capabilities on the edge around analytics and things like that is on the edge versus, just getting data from one system to another. We can take Modbus. I mean, how old is Modbus, right? And old device with Modbus, and we can get it into AI or your SQL database running. But the analytics on the edge is part of what is core to Skynet, where we're focused. And then also we're not doing the analytics in the cloud. That's other people's space to play in. But we can continue to improve getting secure data to them and clean quality data.
I'll go quickly in that, our product is a development platform. So people are developing things every day, right? You saw it does nothing. You go in there, you make connections, you build things out, right? And I get really excited about, the integrators and the engineers that are out there are building impressive things. If we can make them superhuman, leveraging AI to build it better and faster, I think that's an exciting area, so that we can ultimately start focusing on the bigger ROI, value creation that we could do to, get to where all these cool use cases we're talking about. There's a lot of stuff you have to get in place in order to do that. If we can get that done faster and shorter, then that's exciting to me.
Yeah.
And Travis, I'll come back to you if you could share one use case on energy. I'll give you some time to think. Rohit, go ahead.
Yeah. So one of the use cases that we're working without giving any details about it. So we are quite close to implementing one of the advisor using copilots for a physical process equipment, using of course Travis the edge computing, just keeping everything local and creating models and having that equipment be run autonomously, of course with the help of operator looking at it very closely. So yeah, that's an exciting thing. If that goes really well, then we have to include like the security what Gary's talking about, and then scaling up to the entire plant. Yeah, but that's pretty exciting.
I'll just give a similar. I was about to give similar answers and everything else, but I think I thought of something that changed my mind a little bit, which is I'm really excited about how much talk there is that's around not just UNS namespace, but like agentic applications here at the edge and everything else. I would say I do see kind of a marketed difference on either LinkedIn or social media, and even with our customers, this sort of culture of willingness to experiment and try things out. And it's sort of, you have to kind of apply a filter of trust and security. And we've touched on those topics as well. So I think there's really this appetite for, yes, there's a bunch of legacy systems. Yes, we have to deal with a lot of data, but let's try to see if there's a better way to do this. And I do kind of see a temperature change in my conversations with that. So I think that's pretty exciting.
Yeah.
Great. Travis, do you want to? I said I would come back to you. If you have a use case, that's fine. Otherwise, we'll close this panel.
Well, I'll talk about something real quick specific that we allude to it here, but we have to think about, of course, the people that are running these operations. They're most important to this, and we're trying to make their lives better and make it easier for them to run these. I look at, usually you can take a solar site with the best storage. You've got one person running that, right? And they have to manage all the solar cells out there, manage everything that's going on, weather conditions, and data becomes really paramount to them about how that data is actually presented to them and how they use that data. So there's some cool use cases where we unify all that data into the right UNS infrastructure, where now their focus is not so much on watching the screens every day. It's figuring out, what activities can they do to lead to more better optimization, more performance of those sites. You're starting to see a lot of that happen now, and that just it gets exciting because data is gold, right? If we use it the right way.
Great. That's a great reminder who we are working for, right? And whose life we are making easier. That's great, and that brings us to towards end of our panel. Thank you to all speakers here for your amazing insights and knowledge. And thank you for the sponsor of the session, including FaceShift, Anirudh's company, and CyrusLink. And obviously for all the attendees here for listening in and for engaging with us. The next session is, it gets a little bit more into operational side of it. I know we talked about Edge AI here. The next session will dive into that a little bit more. So feel free to log into that session. It's great having you all here. Have a good rest of the afternoon.